Welcome back, everyone, to another explainer. Today, we're diving into something that causes a really surprising amount of confusion in the industry. Look, if you've ever found yourself sitting in a facility layout meeting, kind of scratching your head and wondering about the exact specifications for your power distribution, you definitely aren't alone. Today, we're unpacking everything you need to know about busway specifications, straight from the source material. We're going to cut right through the jargon, streamline those buying decisions, and give you a rock-solid framework for your next project.
So, here's our game plan. First, we'll bust a massive name myth. Then, we'll get into the real buying decisions. Compare feeder versus plug-in systems, look at copper versus aluminum conductors, run through a quick procurement checklist, and finally, look at some real-world standards and applications. Let's get into it.
All right, Section 1, Busting the Name Myth.
So, bus duct or bus bar trunking? Imagine you had to specify one of these for a massive commercial building right this second. Which one would you choose? I mean, what's the actual technical difference here? You'd be amazed. People spend hours in conference rooms fiercely debating which of these terms belongs on the final purchase order.
Well, here is the secret. Bus duct and bus bar trunking are the exact same product family. They are literally identical. The only difference? Regional naming conventions. That's it. It's actually kind of funny when you think about how many billable hours highly qualified engineers waste debating labels when they're literally talking about the exact same system.
Which brings us nicely to Section 2, the real buying decisions.
Because at the end of the day, the buying decision is absolutely not about the label on the box. Fixating on regional names, that only leads to confusion and delayed timelines. Focusing on the actual standards and your system requirements, that is what actually guarantees a successful, safe project execution.
Instead of the label, it all boils down to these 5 specific engineering criteria. You've got to know your rated current to make sure the system can actually handle the load. You absolutely need to know the short circuit withstand for safety. You have to evaluate the joint design. Actually, let me stress that. Bad joint design is a major point of failure, so don't overlook it. You need to decide on the appropriate conductor material, and crucially, you need to know exactly which standard the test report needs to match. If your test report doesn't match the required standard for your specific facility, whatever regional name is printed on the box isn't going to save you.
Moving on to Section 3, feeder versus plug-in busway.
Now, this is a huge fork in the road before your physical layout even begins. You're basically choosing between two very different core functions. On one hand, you have the feeder busway. This is designed strictly for bulk power transmission. We're talking about moving massive amounts of power from point A to point B efficiently, without any interruption. On the other hand, you've got the plug-in busway. This is built for distributed power. If your facility needs power dropped down at multiple flexible points, like in a highly adapted manufacturing plant or maybe a data center server row, then plug-in is your clear path.
Next up, Section 4, copper versus aluminum conductors.
So inside those bus bars, you need to choose your core material, and this choice has to perfectly align with your specific project type. Copper gives you significantly lower electrical resistance and takes up way less physical space, which makes it absolutely perfect for compact high-fault areas. Aluminum, however, is much lighter and highly cost-effective for larger, less constrained runs. You can't just guess here, okay? The material has to fit the exact fault level suitability of your overall project design.
All right, let's pull all of this together in Section 5, the procurement checklist.
Think of this as your absolute, non-negotiable 7-point operational framework. This checklist must be completed before any busway order is signed off. Step 1, determine your layout, feeder or plug-in. Step 2, select copper or aluminum. Step 3, verify that rated current. Step 4, confirm the short circuit capabilities. Step 5, approve the joint design. Step 6, finalize those conductor specs. And Step 7, the big one, match your test report to the required standard. Skip even one step here, and you're just inviting costly failures.
Finally, Section 6, standards and applications.
So what does this actually look like in the real world? Let's take Xinma, for example. They're a major manufacturer out of Shanghai, providing solutions like cable tray systems, busways, and seismic bracing. Notice how strictly their target industries map to rigid compliance standards. Whether they're deploying into data centers, rail transit, industrial plants, or commercial buildings, their products adhere exactly to specific standards like IEC 61439-6, IEC 61537, or NEMA VE1. When professionals are supplying a massive infrastructure project, they aren't out there selling a name. They're selling a verified test report that proves their engineering meets the exact codes required.
And that brings us to the ultimate question you need to ask yourself right now. Does your current busway order actually match the standard, or just the label? I really challenge you to take the 7-point framework we covered today and immediately review your own procurement specifications. Let's stop arguing about regional terms, start checking those test reports, and ensure your layout is built on rock-solid engineering. Thanks so much for learning with me today, and I'll catch you in the next explainer.